Hmm. Right. As usual, if you have any questions first, then feel free to ask. Otherwise, what I might do after that is do a little recap of organic chemistry, which will be relevant to everybody. 5 to 8, year 10 booklet chemistry. Right, since that's the first question, I want to go straight to it. No, that's not it. Organic chemistry. That'll be it. Chemistry, question 5, year 9. Okay. I may just do that first. Sorry, because of one of them. And it might also be repeated. I'm sure it might be. Question 8. Yep, yep, fine. Okay, so I have a few questions, so I'll do those first. Right. Question 5 from this one. Some of these, by the way, might be slightly beyond what you might have done in the lesson. Right. As always, the question is about the Earth's resources. When most fuel burns, carbon dioxide. Okay, I'm gonna get my stuff ready. When most fuels burn, carbon dioxide is produced. Balance this equation. Okay, balancing a chemical equation requires you to count how many of everything there are on each side. So we've got C, O, and H here. We'll have C, O, and H on the other side, and then you just use some counting first. So I've got 3 carbons, and there's 3 carbons on that side because that three is already there. There are oxygens on this side, 2 at the moment. On this side, there's 6. 3 times 2 is 6, plus these 4, so that's 10. Hydrogen, there's 8 on that side because 4 times 2 is 8, and there's 8 on the other side. So the only thing that's not balanced is the oxygen. We need to make the stuff on the left-hand side 5 times bigger. So if I put a 5 there, that means there's now 10 oxygens on the left-hand side and 10 oxygen on the right. The test for carbon dioxide, give the result of the test. The test is to, I mean, if you want to mention the word lime water, so if you want to be really precise about it, then you want to bubble the gas through lime water. Lime water is a transparent, clear substance like water, and the result is that the lime water turns cloudy. You can say milky, according to the mark scheme, or even white. Okay, so I'm currently doing year 9, question 5. Propane can be cracked to produce propene and hydrogen. Complete the symbol equation for the reaction. Propene, I mean, you could sort of guess this. Firstly, it should have been in your notes and stuff in terms of what propene actually is. Propene is the third one down, so it's C3. And because it's an alkene, the formula is that it just doubles the H's. But you could figure this out anyway because you've got 3 C's on the left-hand side, so it should be 3 C's on the right-hand side. There's 8 H's on the left-hand side. There's already 2 here, so there should be another 6 there. That way you get to C3H8. Describe the test for hydrogen. What you do for hydrogen is that you use a lit splint, so some fire basically, lit splint, or a flame. And if hydrogen comes near that flame, then you hear a squeaky pop. And you will remember this if you've ever seen it before. And then propene is an alkene. Describe the test for alkenes and give the color change. So to tell the difference between alkanes and alkenes, you add to bromine water. Bromine water is orange to begin with, and if you add an alkene to it, it goes colorless. That is all of question 5. And now I will do questions 5 to 8 from the year 10 one. I assume there'll be more questions in a minute. Right, here we go. Question 5 there. Uh, Right, so question 5 then here. Draw a line from each hydrocarbon to the formula for the hydrocarbon. Again, you should know this really, but remember, anything that's an alkane has the formula CnH2n plus 2, which means that to get to the number of hydrogens, you double the number of carbons and add 2. For example, if I had C100, double this number and add 2, that is an alkane because it follows that pattern. Whereas an alkene, its general formula is CnH2n, which means that to get from the number of carbons to the number of hydrogens, you just double. So this, for example, with a 200 would be an alkene. And so you just need to figure out which one it is then. So for an ane, we double and add 2. So if you double 6 and add 2, you get to 14. So that should be the one there. And for an alkene, then you would just double. So C6H12. The question about can you explain homeostasis? Is there any specific part of it? Because homeostasis is a huge topic, huge. So any specific part of it would be helpful. Bromine water is added. What would be observed when bromine water is added to hexane and hexene, as per the previous question that I just went through? When you add bromine water to an alkane, there is no color change. But when you add it to an alkene, the orange bromine water turns colorless. Because alkenes react, whereas alkanes do not. Any part that I choose. Okay, I'll choose the bit about um, glucose. Um, this question, which is very, very long, 6 marks. Ethane is an alkane and ethene is an alkene. Compare ethane with ethene. Okay, so I'm going to put a few bullet points here. I'm not going to write it out in full, but their structure and bonding. So what I would say is that ethene has a double carbon bond. Whereas ethane is very hard to read because they're so similar. Ethane only has a single carbon bond. See that single line, whereas a double line. Then I might also say that you're just comparing them, right? So you want to say what's similar about them as well. So you can say both have 2 carbons or 2 carbon atoms, but ethane has 6 hydrogens, ethene has 4. Okay, you could say that ethane has the general formula CnH2n plus 2 because it's an alkane, whereas ethene has CnH2n because it's an alkene. Anything else about their structure and bonding? I don't think I'll say anything else. Their reactions, I would just say that ethane does not react because it's an alkane. So you can make it with bromine water if you want. Whereas ethene turns bromine water colorless. And I think that's more than enough for 6 marks. There is more in here. Kidneys filtering the blood topic. Yeah, I'll try and get to that. 4 and 6 in the year 9. Okay, I'll have to get back to that in a bit. 5 to 8. We said right. Again, I might not do all of this as previously. But what's going on here? Formula. Right, you shouldn't need any help with this, but that's obviously C2H4, just counting what's below it. Propane structure is 3 carbons. When you do these diagrams, remember, if it's an ane, there will be no double carbon bonds. With an ene, there is a double carbon bond. That's the first thing. Secondly, make sure that every carbon has 4 lines coming out of it. So you see how this carbon here has got one, two, three, 4 lines coming out of it. That carbon has got 4 lines. Every H should only have 1 line coming out of it. So if this carbon, there's 3 carbons here. To draw it, I've got space for 3 more hydrogens. So there's got 4 lines coming out of it. This carbon's already got 2, so 2 more. This carbon's already got 1, so 3 more. That would be the formula for propane. This is quite a hard question, but anyway, the answer is, what is the name of the plastic formed? If it was ethene that is being polymerized, we just put the word poly in front of it. So it's polyethene. That's all you do. What type of polymerization? I think the answer to this is addition polymerization, but I'll just double check because you wouldn't be expected to know this really. But that's what it is. It's called addition polymerization. 7 and 8 is all I'm going to do from this one, and then I'll do those 2 year 9 questions, and then I'll do a little bit of the homeostasis things. And that will be that. Question 7. This looks like fractional distillation with a box. Okay. Use the diagram to help you explain how crude oil is separated into fractions. So I'm not going to use the diagram really, but the key things to say is, well, the words that they say here is that at the beginning, the crude oil is heated until it evaporates. Or you could just say evaporated. Um, you then need to say, so what happens here is that when you heat all of this up, the gas goes into here, and as it rises up the column, it cools. So you want to say that. And as it cools, because all of these different fractions of it have got different boiling points, they condense, they cool and condense at different temperatures. Okay. That should be enough, really. Yeah. Okay. Um, use the information to help you answer the question. How can you tell each of these fractions is a mixture? I think it's because it's got a range of boiling points. I think that's the answer. So when you have a mixture of substances, then you have, it's not like they have one boiling point. A compound has one boiling point. If you have a mixture of things, then they've all got different boiling points. So the fact that there's a range of boiling points here should tell us that that it's a mixture. Um, um, and how does the number of carbon atoms affect its boiling point? You can see that as the number of carbon atoms increases, the boiling point increases. That should just be easy enough to write. Um, the reaction that releases energy from a fuel surely is called combustion. Are you sure that is correct? Yeah, you can say burning apparently. Describe how fuel is broken down into smaller, more useful molecules such as gasoline. Um, so I believe this is describing the process of cracking. So when you have fuel oil, which is a long, it's in the diagram, isn't it? So this is a long hydrocarbon. All the long ones are near the bottom. And we often like to turn the long ones into short ones because they're more useful to us. The way we do that is through a process called cracking. And cracking, as far as you're concerned, only involves using a high temperature and a catalyst. Um, Question eight. This is the last one, right, for this bit? Okay, fine. Can I say steam? I can't remember which bit now. Oh, sorry, I was missed that. Oh, for cracking. Not according to the mark scheme that I'm looking at. It just means high temperature under catalyst. Although to be fair, I think you probably should be able to. But anyway, for this purpose, just easiest thing to do, anything to do with cracking, just try and remember high temperature catalyst. That is there's no there's no real detail that you have to learn. That's it. Right, complete this structure for an alkane that has six carbon atoms. So one, two, three, four. There's four carbons so far, so I need two more. Okay, that's the first thing. Then I just remember, firstly, this is an alkane. So there are no double carbon bonds. They're all just single lines. And I just need to make sure that every carbon has got four lines coming out of it. This one has already got two, so it's got space for two more, H, H. This one currently has one, so it's got space for three more, H, H, H. And that is the answer. Um, the boiling points of alkanes are linked to the number of carbon atoms. So as you can see here, as you've got one carbon atom, your boiling point is minus 160. As the carbon atoms increase, the boiling point is increasing in that direction. And that is the answer to the first question. The link between the number of carbon atoms and the boiling point is as the number of carbon atoms increases, the boiling point increases. Somebody else is saying things. By the way, everything that I'm doing at the moment is put onto our YouTube. You can find it. I'll type it in somewhere. But so if you're trying to copy stuff down at the same time, I will decline your request for me to slow down because it is all being recorded and it all ends up on a YouTube page called Step to Success UK. It's usually when I finish, by the time I get home, about 10 minutes later, it's already there. So you will be able to find it. If not, tell us. So you can just go back and pause it, right? This will be easy enough. Um, right. And that's it. Is that it? Oh no, wait. Yeah, okay, nearly done. Right, this gets a bit weird down here. Suggest two reasons why all of the alkanes in the bar chart are better fuels than the alkane with formula C30H62. So all of these fuels have one, two, three, four, five, or six carbon atoms, whereas this one is much longer, C30H62. What do I know about the longer hydrocarbons? I know that longer hydrocarbons are less flammable. So the ones that are shorter, the ones in the bar chart, are easier to burn or more flammable. So that makes them better for being fuels. Easier to burn. Um, the other reason, I mean, you can say that they have a lower boiling point as well, because remember the shorter ones have got lower boiling points. That doesn't quite explain why it's better to use as a fuel, but it's fine. It is an answer. I think the better answer is that the shorter ones are less viscous. Viscous, remember, is the word that means how much it flows or how well it flows. The example that I gave when I taught it was custard versus water. Custard is a thick fluid that doesn't flow very easily, whereas water obviously does flow. Shorter hydrocarbons flow more easily. They are less viscous. Viscous basically means like thick or gloopy. Um, and so that makes it slightly better as a fuel, I guess, because it's easy to transport. If I wanted to send, water through a pipe, it's easy enough. But if I wanted to send custard through a pipe, it would be a bit harder. So them being less viscous makes them slightly better as fuels. Uh, Part C, during the last 200 million years, the carbon cycle has maintained the percentage of carbon dioxide in the atmosphere at about 0.03%. Over the last 100 years, it has increased to about 0.04%. This is mainly caused by burning fossil fuels. We should know all this. Burning fossil fuels, such as petrol, releases this locked up carbon, balance the chemical equation. Okay, nothing to do with anything. So, how do we balance a chemical equation? We count the things we have on the left, CH and O, and then count the things we have on the right, CH and O. On the left right now, we have got, remember, don't forget this big two. This big two doubles the carbons there, so that makes 16 carbons, I believe. This two doubles the hydrogen, so there's 36 hydrogens. And this 25 means that there's 50 oxygens, which is reasonably large numbers. I need to do the same thing on the other side. So I guess if I want 16 carbons, I'm going to have to put a 16 over here because that means I've got 16 carbons. Fine. And I've also now got 32 oxygens plus that one, which is 33. Okay. And I've got two hydrogens here, but I need 36 hydrogens. So what I'm going to do is put an 18 here to balance my hydrogens. 18 times 2 is 36. So I've now got 36 hydrogens there. And also I've got 18 oxygens plus these 32 oxygens, which has magically made my oxygens 50 as well. And everything is balanced. Where did the carbon that is locked up in fossil fuels come from? So this is about understanding the carbon cycle. It originated from, you can say from dead plants and animals, if you like, because they've kind of taken it in. You can say a better answer really is just from the Earth's atmosphere. That's where it came from. So, very quick summary of what the carbon cycle is. There's carbon dioxide in the air. Plants take it in due to photosynthesis. Take it in CO2, right? Then those plants have got loads of carbon in them. They could get eaten by people or animals or whatever. Eventually, everything dies. Oops. This is supposed to be a dead person in the ground. Okay, oops. Yep. Okay, yep, there we go. And plants, everything ends up in the ground. Right. So all of that carbon, which was originated in the atmosphere, got taken in by plants for photosynthesis. Then it got either eaten by people, regardless, everybody died, everybody ended up in the ground. All that carbon's in the ground. Over millions and millions of years, it reforms as fossil fuels, which would stay as they are if it wasn't for humans. Humans come along and burn those fossil fuels, putting a lot of CO2 back into the atmosphere. And that is essentially the carbon cycle. What's somebody saying? Decomposes. Yeah, so I've kind of skipped. I've summarized that very very briefly, right? But there's more to that process. Um, Decomposers are things that make things rot away. So when plants die, they have to decay. So there's like bacteria and other decomposers that make those things decay. And during that decay process, some carbon dioxide also gets released because bacteria respire and release carbon dioxide just like we do. So as they're feeding off all of this dead stuff, they release CO2 as well. So that's the cycle. So there's two places where it's going back from the respiration of the decomposers, burning fossil fuels, but it's being taken in um, by plants, and then that whole thing is called the carbon cycle. Um, but again, I've simplified it a little bit. But that is why we're meant to plant more trees. The burning of fossil fuels has caused the percentage of carbon dioxide to increase above 0.03. Explain why. Well, what is the answer to that question? The burning of fossil fuels caused the percentage of CO2 to increase to above 0.0. Explain why. That's a really vague question. I'll tell you what the mark scheme says. The mark scheme mentions that there has been an increase in the burning of fossil fuels now, which is basically repeating what it says there, but increase in the burning of fossil fuels. Um, and what's happened is that what was these fossil fuels had loads of locked up carbon dioxide. It was locked up in the sense that it was just stay underground. If it wasn't for humans, all of that carbon would still be underground effectively. But we have now drilled it all up and burn it, and that releases it back to the environment. So we want to say that the locked up carbon dioxide is released. And that should be all of that question, hopefully. Yes, it is. Right. Okay. Given that there's no more homework. Oh, no, there was maybe one more. Chemistry question 4 and 6, year 9. Right. Let me just do that and then I will move on to some of the other questions. Right. Question. Okay. Right, I'll do this really fast. Crude oil is formed by the decomposition. Now, you know what? This is a good question actually to come across for everybody. But when it comes to crude oil, for this specific question, it is very easy to mention just dead plants and animals. But you need to specifically, for crude oil, mention something called plankton. Whoops. Which is a type of sea plant, which is what ultimately causes a lot of the crude oil to form under the sea. Give the name of the alkane that has three carbon atoms. The naming of the alkanes are methane, ethane, propane, butane. So the third one is propane. Make sure you put ane. Um, and then compare the structures. Very similar question to we did earlier. Compare these two. So say the obvious, which is that this has got one carbon, whereas the other one has got six carbons. Say that this has got four hydrogens, whereas this has got 14 hydrogens. Okay, say the obvious stuff first. Um, you could say, remember, comparing doesn't always just mean differences, it means similarities. So you can also say that they both, if I know I was going to say something, but that doesn't make sense. Um, yeah, you could say that they both have the general formula CnH2n plus 2 because they're both alkanes. Because they're both alkanes, we often describe them as being saturated, which means that they don't react. You could also even say that both of them will, or neither of them would, sorry, in bromine water, it would stay orange. Remember, so alkanes keep it orange, alkenes turn it colorless. So bromine water stays orange with both. You could then mention the other obvious point, which is their melting and boiling points. Methane has a much lower boiling and melting point than hexane. I think I state all of these obvious things, and I think that's probably enough for 6 marks, really. Um, you could say because hexane is longer, it is also less flammable because the shortest ones are more flammable, the longer ones are less flammable. Um, I think that covers that. This equation, complete the equation, it's just counting. So on this side, we've got 10 carbons. We need to have 10 on the other side. So 8 and 2 makes 10. We've got 22 there. We've got 4 there. So we need 18 there to make it all balance. Um, 4 and give the result of the test of alkenes. So again, the test is that you add it to bromine water. I think I did this earlier. And bromine water turns colorless because it's an alkene. Okay. And then question 6. Which of these hydrocarbons are gases at room temperature? This is often people get this wrong actually, so I just want to make sure I clear this up. If we go with water, water has a boiling point, let's say there, and a melting point there. So obviously in our case that would be 0 and 100. Okay, but we know that on this side of the boiling point it is a gas. On this side of the boiling point it is liquid. So if something, and room temperature is what here somewhere, right? 20 degrees, which means that we know that because the boiling point is above the room temperature, it's a liquid. Okay. Um, now, if we wanted something to be a gas at room temperature, it would need to have a boiling point less than 20. Do you see what I mean? So that would need to be its boiling point. And so if that's room temperature, sorry, room temperature, then if we want it to be a gas here, we need its boiling point to be less than 20. So anything that's less than 20 should be the answer here, which is just going to be X and Y. It's probably an overly complicated explanation for that question. Um, but yeah. Which of these hydrocarbons have the largest molecules? Things that have very high boiling points tend to be the longest or the largest hydrocarbons. So the one with the largest boiling point, which is Z, must be the one with the largest molecules, and which is one ignites most easily. Shorter ones are the most flammable. So, and shorter ones also have the lowest boiling point. Quite a complicated question that. So it's the one with the lowest boiling point, which is the most flammable, which is X. And which type of hydrocarbons can be converted into polymers? Again, you might not know the answer to this, but it is alkenes. Some of these questions just go a little bit too far. Um, um, year 8, question 5B. Um, just 1 second. Right. That should be that done. Right. I'm going to move on. Just I've just answered that question. Just to confirm, in these sessions, I appreciate some of you might be here because of siblings and stuff, but I just because of time and different complexity, I tend to only go over the year 9, 10, and 11 um homework questions in these sessions. Anybody else that happens to be here, you're welcome because you might have got the link. But I will deal with your specific question in the actual lessons. Um, So, there's too many things to do otherwise. Right, let's see what else I need to do. So, right, Safa, you've asked about chemical cells and fuels. I believe I did some of this in one of these not that long ago, but I'm not going to be able to find it now. But what I'll do is I'll specifically sit down with you on Saturday and do some of the chemical fuel cells stuff. Just I won't get to it now, I don't think. There has been oh, what I'll do is because I definitely went through it at some point. Let me see what I can find. I would recommend somewhere here. I've got something to do with fuel cell. I don't know where it is. It's in the first topic, isn't it? I would recommend if you need that and you don't have this, then just contact me and I'll send you these notes. There is a video on it as well, which I must have done at some point in the past. But the stuff on fuel cells and batteries, I think everything you need should be in this. The key thing with this topic is well, there's a little about hydrogen oxygen fuel cells, which you probably do need to read through. But the bit before here about the batteries is quite simple, really. It's just the bigger the number that you get here, the bigger the difference between the reactivity of the electrodes. But I will go through it specifically on in the next lesson. Right. The remaining thing I will do then is talk, if anybody is interested, about the kidneys, because that covers the two bits of homeostasis questions that have come propped up just now. Um, and I'll just go through it on these notes because I will almost certainly have something here that says controlling water content. And this should um, be enough for covering that topic, but I need to bring it down here. So yeah, we might only go until about 8 o'clock today. I appreciate I vary the length of these things. Controlling water content. Um, right, the kidneys. So the question about the kidneys. This is the bit that I'll finish off with. So first of all, I should just say one thing, that if you end up doing combined science, or if you are here and doing combined science, then this particular topic you probably don't need to know. And I only say probably because different exam boards are a bit vague. If you're doing AQA, then it's definitely not in it. But it is in triple. So you just follow along really. Um, it's just interesting if anything. So the in homeostasis, one of the first things that I say to people when I teach it is I say that you learn three things with regards to what our body has to control. There's temperature. So we have to keep that, prevent that from getting too high or from getting too low. So that's one thing. So there's things like sweating and shivering and vasodilation, all that jazz in those topics. Paper one or paper two. AQA, it is paper two, because all of homeostasis is in paper two. I can't answer it for any other exam board at the moment, but it's in there somewhere. Temperature. There is blood glucose. When that gets too high or too low, we have hormones called insulin and glucagon, which help to bring our blood sugar. I'm going to repeat this again. If your blood glucose level is high, insulin brings it back down. If your blood glucose level is too low, glucagon, which is lovely named glucagon, is the hormone that brings it back up. Um, so that's for blood glucose, and then you learn about diabetes and all this stuff in that, right? Then the other thing is water. The amount of water in your body also needs to not get too high or too low. If it's too low, then obviously you can be dehydrated and so on and so on. If it's too high, it can affect your cells because there'll be too much osmosis going into your cells and all this other stuff, right? So we just need to keep it the same as much as possible. And what controls the water level in your blood is mainly the kidneys. That's what they are doing. Um, so as it says here, the kidneys, oh God, help regulate the water content. What they do is they make urine by taking waste products out of the blood. Now, this is the bit that's technical, right? So let me try to explain how this works. It's unnecessarily complicated, but I appreciate it's been designed, I'm sure, for a good reason. Um, where your kidneys, let's pretend that's a kidney. Okay. Um, and let's pretend, I'm going to do it over here actually, because I've got colors here. Right, here's your kidney, right? Here is your blood. Your blood, let's say, has got loads of different things in it. Okay, there you go. So all that stuff is flowing through your blood. What your kidneys do first is they basically take. Oh God, I can't do this, can I? Because of the. Right. Let me just get rid of this line. Okay. Right. What your kidneys do is they take all of that stuff and filter it. We say filter it out of the blood. Okay. So imagine you put a big giant sieve there. So the blood, sort of the liquid, the small stuff goes through, and all the bigger stuff comes out into the kidneys, a bit like yeah, literally filtration, right? That's what happens in filtration. So it gets filtered out, right? What they then do, yes, there's the blood again. They then look at what we've taken out of the blood and decide what we should keep and what we should get rid of. So, for example, if they've filtered out, let's say this is all the water that was in your blood before. And let's say it's a very hot day, right? And what you don't want, and you need to, and you basically not got that much water here because you've sweated a lot of it out. What they want to do is make sure that we don't remove even more water from your body. So what they will do on a hot day is essentially send that water back into the blood. We call that reabsorbing. They reabsorb the water that we want to keep. And let's say these are various ions like salt and all these other things that you have flowing around your body. Again, what they will do is they will look at, is there too much of it? Is there too little of it? If there is too much of it already, then they will reabsorb less of it, right? So they'll just put back what should be in your blood. Okay, they'll put that back. And then the rest of it that they don't want to keep, they will send to your urine and you will get rid of it. Okay. And so, for example, if it was a much colder day, then they would have said, well, we don't need all this water in the body because the thing's too cold. So in that situation, there would have been more water here, less water would have gone back into your blood, and you'd have produced more urine because there'd have been more water in it. So on a hot day, you tend to produce less urine because your body is trying not to lose any more water. You've probably sweated already, and you don't want to get rid of even more water and feel more dehydrated. So you end up producing less. On a cold day, your body is going, well, you haven't got rid of that much water today because you haven't sweated, for example. And so you will probably produce more urine because the kidneys will send more water to the urine. Sorry, yeah, they will send more water to the urine and they won't put as much back in the blood. So the kidneys are just controlling, do we want to keep it in the blood or do we want to send it to the urine? That's essentially what the kidneys are doing. So as it says here, useful substances including all the glucose, some ions, and the right amount of water, are then reabsorbed back into the blood. It's called selective reabsorption, where they decide what do we want to keep. So there's three things to remember. They'll always at this point, they will have also filtered out. I've run out of colors. They'll have filtered out some glucose. Let's pretend this is glucose. They'll have filtered that out of the blood because it's just a bigger thing, right? That's just come out. But the kidneys are not in charge of controlling the blood glucose level. So what at this point, what happens is all of the blood glucose is reabsorbed. It's just sent back. Because remember, your blood glucose is controlled differently. You don't lose glucose in your urine, for example. So even though they filter out the glucose, they then put it all back. So they put back all the glucose, and then they decide for the ions, like salt and so on, and water, they decide how much should be reabsorbed back into the blood. Um, and that just depends on the level of it. They're always trying to keep it at the same level. If there's too much of it in the blood, they won't put as much back. The more will go to your urine. If there's too little in the blood, none will go to your urine. They'll put it back in your blood. You see what I mean? They'll just balance that bit out. The substances that are removed from the body in the urine include urea. Fine, that's just nothing to do with the kidneys. Right. The main focus now is on the water content. So, as I said here, on a cold day, we sweat less, we produce more urine. On a hot day, we sweat more, produce less urine. There's some color-related issues with the urine here. Um, so, focusing on the water, how does the kidney know whether to keep the water or send it, as in send it to the urine or to put it back in the blood? How does it know? The answer is through a hormone. So if you remember, you may not, but if you remember that in the topic of blood glucose, you learn about hormones like insulin, which help to bring your blood glucose level down when it's too high, glucagon, which helps to bring your blood glucose level back up when it's too low. In the same way, there is a hormone that indicates what to do with the water, and it's called ADH, antidiuretic hormone. It is the hormone that is released by the pituitary gland. Does it say somewhere? Mhm. Yeah, it does. The pituitary gland. And what that does is it basically tells the kidneys whether to keep the water or to let it go to the urine. That's what it does. And so the way it works, there's a little bit of a technicality here about permeability, but I'm not going to go into that for now. I'm just going to focus on this, which is this little table here. Right. So let's pretend that it's been a hot day and you have sweated a lot. So a lot of water has exited your body already, and you don't want more to exit. Um, your brain will receive all this information. Remember that whole nervous system stuff, like your brain receives the information. And what it will then do in response is it will release more of this hormone called ADH, right? Because what that tells your kidneys to do, so more ADH, it tells your kidneys to reabsorb more water. So at this point here, let's go back to all of this. Right, we've filtered out all of this water. And the kidneys now need to decide whether we want to reabsorb. So this way would be reabsorb the water back into the blood, or send it to the urine. Okay, when you decide which one we're going to do. Now, the ADH will determine what it does. If there's more ADH that's been released by the pituitary gland, which is controlled by the brain, then what it will do is it will reabsorb more of this water. It will put it back into the blood because it's a hot day. And it's like, well, we don't want to lose all that water because it's a hot day. So I'll put it all back. However, if it's been a cold day and we need to get rid of some of this excess water, we don't want to keep so much of it, then the brain would have released, or the pituitary gland would have released less ADH. Less ADH will mean that less of this water is reabsorbed. So rather than it going that way, it will go this way to your urine, and then you might just reabsorb this much. You see what I mean? Obviously, you'll still reabsorb some of it. So the ADH will control whether we want to, whether the kidney reabsorbs the water or it doesn't. And the way I used to remember it is simply this. More ADH means more water reabsorbed. So more and more. Less ADH, less water reabsorbed. And you would reabsorb more water, surely, when it's a hot day because you've already lost so much of it. So reabsorbing means keeping in this context. You keep it in the body. Whereas if it's a cold day, then you will reabsorb less water because you don't need as much of it. And that's what this table essentially says. It says what happens when it's you more ADH, the more is reabsorbed. Whereas if it's a cold day, for example, and there's too much water, let's say you've been drinking loads constantly, just all day, just sipping on water, then your brain will, the pituitary gland will release less ADH because it'll tell the kidneys we don't need to reabsorb too much water because we've already had quite a lot of it today. So you'll send more of it to the toilet. Um, right, I'm not going to go into kidney failure and kidney dialysis because it's a slightly more complicated topic, but hopefully that just summarizes a little bit of the homeostasis. And I've already talked about some blood sugar level in that particular conversation anyway. Um, but yeah, kidney dialysis is like the equivalent of, I mean, in terms of it's not the equivalent, but in terms of the education bit of it, it's like the equivalent of diabetes, which is okay, now the kidneys don't work. What do we do? Similar to like the pancreas doesn't work. What do we do? It's a bit like that, right? It's nothing, they're not related at all, but that's one way of thinking of it. Okay, right. Assuming there's no other questions, and I've done a little bit of what everybody asked me to do. As I said, the question about the fuel cells, I will deal with that at the weekend if that's okay. But if you need those notes that I just mentioned, then just contact me and I will give them to you if you don't already have them. Right. What kind of exam questions would they ask for this topic? Oof. Well, I mean, to be honest, the bit I've talked about so far, maybe they would ask you the name of the hormone involved. They might ask you what happens when, in terms of when it gets too hot, in terms of this hormone being released. I see more questions, to be fair, slightly more questions on the actual kidney failure bit of it. Because there's a bit of a complicated thing about dialysis machines here, which is quite complicated, but really clever, but quite complicated. I mean, the best way to answer that question for you when it says what, when you say what kind of exam questions, I would do the following, just to give you a guide before we finish. Um, like go to AQA, physics, GCSE. Go to yeah, just go to that. Um, Go to assessment resources. This is going to be in paper two, firstly. So, I mean, this might not work what I'm about to do, but I'm just going to go with it. Sorry, why am I doing physics? It's biology. Apologies. Don't do that. Um, right, do that. Um, and then yeah, find paper two, and then just go through it because this is and there'll be something on it in here. I just don't know exactly what will be related to what we just talked about, but there will be something on here. Because it is in paper two. We'll see if I can find it. That's birds. There might not be actually, because the problem is homeostasis is such a big topic that it's hard to get questions on all of it. There is a homeostasis question here. I think that's more to do with glucose. Thyroxine is also in the ADH is a hormone made by the pituitary gland. So what you could do, I'm not going to do this now, but well, my point is there is a question here about ADH and hormones and stuff, which is to do with the kidneys. There is a question here on an exam paper that I've just found very quickly. You could look at this question, see what it says, look at the mark scheme, and that gives you an answer to your question of what kind of exam questions would they ask for this topic. Um, that's the thing I would do. And they do the same thing going back a few years, the papers that are available. As long as you know which paper these topics appear in, it's very easy for you to go and quickly find some questions on them because you just navigate to the correct place and do that. Right, I think that's it for now. I've got somebody who's trying to call me. If you have any other questions, WhatsApp number, as always. And otherwise, I'll see you when I see you.